right, so let's do this last section, and then I'm gonna remember I'm going to briefly go over how to solve the problems one more time before we call it a day. That way you can see it one more time before we do it. And then that's the only section we teach tomorrow, and then we'll start our review for the exam. All right. So laws of logs. Okay. Most people don't say logarithms; they just say logs. And yeah. So here we have the same caveats: a is greater than 0, a is not equal to 1. We're gonna let a, b, and c just be real numbers, so just some real numbers. I'm gonna let a and b be greater than 0. And the reason we're forcing a and b to be greater than 0 because we can't have logs of negative numbers. Okay, remember we can't take a log of a negative number. Log is clearly only defined between 0 to infinity. All right, so what we have here is log base a of a times b is equal to log of a times plus log of b. Okay, and let me kind of give you why that might be, but not really. Um, Notice that if we have log of x plus y, that's equal to log of x times a log of y. And so somehow, some way that this multiplication turns into addition is kind of how this multiplication turns into addition. Now, is this kind of vague? Yeah, I'm not giving you the whole picture. I'm not doing a proof, but I'm just saying, where does this come from? And then if we have a over b, e minus the two exponents. Okay, so remember this is, uh, it's not quite that, but it's kind of where it comes from. A to the c, well, raising an exponent became this. And so these are the rules. These are our rules. These are derived from these rules. Um, so let's just go through them slowly. All right. So here's what I like to do, and I'll show you how I do this. So here, if I have log base 2 of 4 plus log base 2 of 8, that means I can write this, so I can put these together. Why? Because I have a 2, I have the same log, and I'm adding them. That means I can multiply them together. So 4 times 8. I have 4 times 8. That's equal to log base 2 of 32. 4 times 8 is 32. And then 2 raised to what power is 32? Well, that answer is 5. So we can evaluate that to be 5. Here I have log base 2 of 80 and log base 2 of 5. Well, here I can write that as log of 80 over log of 5 base 2. And 80 divided by 5 is 16. So I have log base 2 of 16. Well, 2 raised to what power is 16? Why, that's 4. And so you can answer some questions here. You can evaluate logs um, using, using these rules. Here, I can move this on top of here. So here I'm going to say log of 2 is equal to 8 to the negative 1/3 power. All right, so what can I do with this? Well, that's the same thing as log of 2 over 1 over the cubic root of 8. Well, what's the cubic root of 8? Well, the cubic root of 8 is 2. So this is the log base 2 of a half. So 2 raised to what power is a half? Well, it's negative 1. Is there another way of doing this? Sure. You could have just calculated it directly. Log of 2, 2 raised to what power is 8? Well, that's 3. So 3 times a negative third is also negative 1. And so that, in this case, I took the long route. And I took the long route to show you how to use, here I took multiplication, turned it into an exponent, and evaluate and push through. So I did the long route on purpose to show you how to use that. All right, so here expand the following. So here we're going to go backwards. Here I'm going to use this and I'm going to expand it out. So here I'll have log of base 5 of 6 plus log base 5 of x plus log base 5 of y. Now here, notice here, if I had, I could I could write this as an A, split this two, and then have the Y here, and then do the rule again to get it here, but you don't need to. Multiplication inside turns into addition. So you can just write this one plus this one plus this one. So you don't have to break it into steps. You can just go for it. Here, I'll take ln of x cubed. So here I'm going to use this first rule right here, y squared. And then here we're just going to we can turn this exponents. Exponents can turn into addition, so this will be 3 ln of x plus 2 ln of y. All right. Now let me show you what I do, what I personally do for this. So here I could write this as this over this. What I personally do, if it's on top, it's addition. If it's on bottom, it's subtraction. That's all you need to do, right? And I'll show you how how to use that. So here I'll have positive ln of x cubed minus ln of the square root of y minus ln of z squared. So if it's on the bottom, I put a negative sign on it. If it's on top, it's a positive sign. Now, and this always works. This always works. And so you can just do that instead of having to figure out, oh, is this on top? Because if I divide this, it'd be this plus this, right? And then I move in the negative. Don't worry about it. If it's in the numerator, it's positive. If it's in the denominator, it's negative. That's all you need to worry about. Then here, you can just pull these out front. So this will be 3 ln of x minus a half ln of y minus 2 ln of z. So that's where we're at here. Okay. All right, so here we expanded. We're going to combine. This is more what we're going to be using currently to solve our stuff. All right. So here, if we're going to combine this all into a single function, I'll move the 4 in and I'll move the 2 in. So I'll have ln of x plus, or ln of x to the 4th plus ln of x plus 1 squared. So now I'm using this rule here in reverse. I'm going to take the c and push it in. So here I'm picking 4, making an exponent, the 2, making an exponent. So this all, and then I'm going to multiply them together. So I have ln of x to the 4th times x plus 1 squared. Okay. For b, once again, you don't have to worry about what goes where. Here, I'm just going to move, let's move in the exponent. So I'll have ln of y to the 4th minus ln of the x cubed plus ln of z. All right, now when we put it all together, if it's positive, if I have a positive here, so this is technically positive, right? If it's positive front, it goes in the numerator. If it's negative, it goes in the denominator. This is positive, it goes in the numerator. And so we have ln of y. Okay. Another way of doing this, let me just show you another way real quick, is here I can move in ln of y to the 4th. I can move in the negative. I could have ln of x to the minus 3 plus ln of z. And then here, when I put it all in, I'll have ln of y to the 4th, x to the negative 3rd, z. And then this will just evaluate to y to the 4th, z over x 3rd. Okay. I kind of prefer leaving it this way. Just my preference in dealing with things. So that's that. Seeing how I've already used space for D, it's like, oh, isn't this going to be big? Don't you need that space? Well, look, here I have a 5. Here I have a 5. Here I have a 7. Here I have a 9. Since these are not the same, we're done. We can't do anything, right? There is no combining this. If they are different numbers here, me see if I can circle that a little bit better. If these are different numbers here, we're done. You cannot put log base 5 with anything with log base 9. You just can't. Okay, but these are all the same. This is a 7, this is a 7, this is a 7, so you can. And so what do we have here? Well, here, now that I've taught you all the rules, I'll show you how to just go for it, right? I'll show you how to just go for it all in one step. So we log base 7. I have positive things and I have negative things. So I know I'm going to need to put in this, okay? All right. So this will be x plus 1 squared, right? Move the square, so the square can come in, and that's positive stays up here. Here I'll have x minus x plus 1, but negative, right? I can do it right here. And then here I'll have x plus 3, and then this time will be cubed. Okay. Then actually we can simplify that. Here we can simplify that to be log base 7 of x plus 1, x plus 3 cubed. Oh, that's really hard to read. Hold on. I'll have to cheat the system. Oops. Seven of x plus 1, x plus 3 cubed. So here, notice that this would cancel that. And so this is what we get. All right. Could you have done this before? Sure. Another way of doing this is I could have simplified this to log base 7 of x plus 1, because here I have something, and I have 2 of something, and this is just something, right? Minus 1 of the same something. I can simplify that to log base 7 plus 3 log of 7 of x plus 3. And at that point, I can just simply jump to that step. Okay, so I want to show you multiple ways of working with this so you get comfortable. All right, so let me zoom out and maybe copy that. And we'll go from there. All right. Okay. Let's do this last page real quick. All right, so this last page. And if you need to, I can go back to the other page. So change the base formula. So here we have log base b of x. Well, I can write that as log base log of a of x and log base a of b. So this is the same as this. So what do we use this for? What do we use this for? What we use this for, oops, sorry. What we use this for is to calculate log base 3. So most calculators will have an ln function, ln of x, and a log function of x, and that's it. So you either have log 10 or log or natural log. Most handheld calculators. Now, what do we use these days? We use stuff like Wolfram Alpha, and you can just type it straight in. But some of your, once you go back to class in person, you probably will have like a TI-89 to allow you to use for most of your exams. So how do I type in log base 3? Well, let me teach you. We use this rule. So here, I just use natural log, right? I just use natural log of 6 over natural log of 3. So here, the base goes on the bottom, this goes on top, and it doesn't matter what log of A you use. So I 90% of the time just use natural log. You type that in your calculator, it's going to pump out 0.363. Okay. And I'll type in the last one. Or maybe your calculator only has the log function. Well, you can just hit log of 20 over log of 7. Crunch that through a calculator and you get 1.54. And here I'll show you both. So here will be this ln of 6. And this is equal to 1.58. All right, so what do we have here? Let me show you this in Wolfram Alpha. Wolfram Alpha. Thank you. So let's go to Wolfram Alpha here. So let's pretend I want to type in, oh, let's just do this one. So in Wolfram Alpha, I just type in log base 3 of, guess what it's doing? It's doing, remember in Wolfram Alpha, this is natural log. It says, well, that's the natural log of 6 over the natural log of 3. Or it gives you the decimal approximation. So when I type in ln of 6 divided by ln of 3, because that's what you'll actually type in your calculator. When you calculate that, you'll get the same answer. Now, Wolfram Alpha has a table somewhere of all the log functions. It was already pre-calculated out. Way back in the day, in the before times, right? Logarithm books. In the before times, you used to have to use, use these things called log books, right? And you just look up, here's the log, here's this, and you just have to look up sine, cosine, and logs. And so even when you do the sine, cosine, and all this other stuff, you just have to pull up these huge mathematical table books, and then you just run your calculations from there, right? Here's common logs, and you just, it was just awful, right? It was just awful. Every time you had to look up all these numbers. Um, we don't do that anymore. Be grateful for that. You probably don't even have to do this part. You probably just can go straight to writing log base 3 of 6. And so that's what we have to do in the before times. Anyways, so that's the end of this section.